Okay, let's take a look at question 5. This is when we start getting into our trig, and I know it gets a bit iffy with you guys, so I'm going to try walk through it slowly so that you can understand what you're looking for. Okay, so 5.1 says without using a calculator, so you need to show all of your steps. Write the following expressions in terms of sine of 11. Okay, so guys, what that means is as long as you have a sine and 11 degrees in your answer, that's what they're looking for. So if I get an answer of like sine squared of 11 degrees, for example, that's fine because you still have the sine ratio and you still have the 11 degrees. The squared is inconsequential. Okay, so 5.1.1 says sine of 191 degrees. Okay, so when you do this kind of thing, guys, you want to try and express this 191 degrees in terms of 11. So if I say sine of 11 degrees, how do I get from 11 to 191? I add 180 degrees. Okay, this is easy peasy. So remember, in your cast diagram, 180 degrees plus theta will give us something like that, because remember, this is 180 degrees plus another theta, okay? And remember, sine is negative in that quadrant, so we get negative sine of 11 degrees. Okay, so easy peasy. In terms of sine of 11 degrees, we just have negative sine of 11. 5.1.2 says cos of 22 degrees. Okay, so ignore the cos for now. What is 22 to 11? 22 degrees is equal to 2 times 11. Or you could say 11 degrees plus 11 degrees. Your choice. I'm not going to use this one because that's a double angle formula and it's going to take a lot longer than is necessary. So we can say that cos of 22 degrees is the same as cos of 2 times 11 degrees. Okay? And now we're trying to get in terms of sine. Okay? So remember, there are 3 different expansions of cos of 2 theta. Okay? They will all be given on your diagram sheet. Very important. But the one that only involves sine is 1 minus 2 sine squared of 11 degrees. Okay, so we have our sine and we have our 11 degrees. These two numbers, the 1 and the 2, are just things that we're doing to them. There are no other functions involved. It's just sine and 11. Okay, so that is a perfect answer. 5.2 says simplify this whole nasty expression into one single trigonometric ratio. Okay, so either in terms of sine, cosine, or tan. You can only have one of them in your answer. Okay, so let's take a look. Cos of x minus 180 degrees. Okay, so if we have our angle of x here, and we minus 180 degrees, we're going to get to about there. So we're going to end up in the third quadrant, okay? Guaranteed, because this is an acute angle that sits in this whole quadrant, okay? X is always an acute angle. So if we subtract 180 degrees, we're always going to end up somewhere in the third quadrant. And remember, cos is negative there. So we're going to have negative cos of x, okay? Let me get rid of this so I have some space. And now, the second part, okay, so we've got the root 2. That's multiplied by anything that we do. So now we have sine of an angle plus an angle. So we need to expand. So we're going to get sine x multiplied by cos of the second angle, which is 45 degrees, plus cos of x multiplied by sine of the second angle. This expansion is also in your formula sheet, guys. So don't try to learn it off by heart, it's fine. So we still have negative cos of x plus the square root of 2 multiplied by everything in the brackets. So sine of x stays the same. Cos of 45 is 1 divided by root 2. Okay? Plus cos of x, which stays the same, multiplied by sine of 45 is also 1 over root 2. Okay? So now we keep going. Negative cos of x plus. Okay, so now if we look here, if we multiplied out the bracket, we would have root 2 times 1 over root 2 for both of these terms. You've got a 1 over root 2 there and a 1 over root 2 there. So those two are going to divide into each other to give us 1. So essentially, these terms cancel each other out. Okay, so we're going to get plus sine x plus cos of x. Okay, so now if we look here, negative cos of x plus cos x gives us 0, and then we're left with sine of x, and that is one single trigonometric ratio. Okay, easy peasy. 5.3 says, given that sine of p plus sine of q is equal to 7 over 5 and p plus q equals 90 degrees. Okay, remember these are angles, hey? P plus q equals 90 degrees. Without using a calculator, determine the value of sine of 2p. Okay. Firstly, let's interpret this statement over here. This is basically saying that if we have a 90-degree angle, no matter what the two angles are, if we divide this into two separate angles, it doesn't need to be 45 degrees and 45 degrees. We could have P there and Q there, but they will always add up to 90 degrees. Okay, so remember that. This also means that P is equal to 90 degrees minus Q, or that Q is equal to 90 degrees minus P, whichever one you prefer working with. Okay. So now, secondly, determine the value of sine of 2p. Okay, what is the expansion of sine of 2p? There is only one of them. It is 2 sine p cos p. Okay, so how do we get cos involved in terms of the angle of p? Okay, so if we look at this over here and we expand it, we are going to get sine of p, which is what we already want. We want it in terms of p, okay? But sine of q, remember, your co-angles or your co-ratios, we can say is equal to cos of 90 degrees minus q. Same angle, remember, to get your co-ratio, okay? And remember what we said here, 90 degrees minus q is equal to p. So we can say that sine of p plus cos of p. Because we said over here, to get to cos from this sine over here, we use a co-ratio. That's where this 90 degrees minus q came from, to get to cos. But we also established that because p plus q equals 90 degrees, cos of 90 degrees minus q is the same as cos of p. Okay, so now we have our sine p and cos p. But how do we get the product of twice of them? Well, if I say to you, expand x plus y squared, you're immediately going to give me x squared plus 2xy plus y squared. Okay? And doesn't this over here kind of look like this over there? It is 2 times the product of two numbers. So if I take this whole equation, the whole equation with the numbers, and I square both sides, we've already established that this left-hand side is this expression here. Okay, so if we say the left-hand side, all squared, is equal to the right-hand side, all squared, let's see what we get. So we're going to get sine squared of p plus, I'm going to write this in a different color, 2 sine of p cos of p plus cos squared of p. That is going to give us 7 squared is 49 over 5 squared, which is 25. Okay, so we have this situation over here. 2 sine p cos p, which is that expansion over there. So how do we get that on its own? Well, remember, guys, sine squared of any angle plus cos squared of the same angle is always going to give us 1. So those two there give us 1 plus 2 sine of p multiplied by cos of p. And the right-hand side stays the same. Okay, so now we have a number value plus that expansion that we needed is equal to another number value. So to isolate that expansion that we needed, 2 sine of p multiplied by cos of p is equal to 49 over 25 minus, because we're subtracting 1 from both sides, but 1 in terms of the denominator of 25 is 25 over 25. So that means that 2 sine of p multiplied by cos of p is equal to 49 minus 25, which is 24 over 25. And therefore, sine of 2p, which is what we got asked for in the first place, is 24 over 25. Okay, so remember guys, when you get a question like this, look at what they're asking you to find the value of. Obviously expand it so that you know exactly what you're looking for, and then try and understand how you could get an expression like this from an expression like this one. Okay, so in this instance, the 2 sine p cos p looks exactly like the middle term of this kind of expansion over here. Okay, so then you work with it, and you know that if you get sine squared of p plus cos squared of p, if the angles are the same, sine squared plus cos squared is always going to give you 1. Okay, so when you're dealing with that kind of thing, guys, remember your identity. Sine squared plus cos squared of the same angle is equal to 1. If you can get that, you already have a numerical value for that, and you can start working with other things. Okay, so look at your trig, make sense of what they're saying. If they say that p plus q is equal to 90 degrees, your co-ratios become a lot more interesting. Okay, that is question 5.